Alright, so we're going to be building the distiller now, guys. Now, what is a distiller? Well, we got this oil made from plastic waste, and this oil, as you can see, is completely black. It's like crude oil. This needs to be refined for us to get out gasoline, diesel, jet fuel, etc. before it can go in an engine. And the distiller is the next step after the step of running this machine to refine the oil that comes from this machine, so we can put it right into engines. Because if we were to put that black stuff into engines, then what it pretty much would do is probably clog the engine and dirty up the injector. It's just a bunch of nonsense, bollock stuff that's going to happen in it. So we're not going to have that happen. We're going to build this distiller. I got this helium tank here. Actually, this was a refrigerant tank. Pretty much empty. Completely empty now. What we got to do is chop off these handles, weld on this 2-inch ferrule here. We're going to put it on right there. Boom. So now, let's go ahead and do this. Enough talk to get to this bloody distiller. Alright, tri-clamp fitting welded on. Next, I gotta do the same thing to a propane tank, and this is going to be the carbon collection discharge propane tank. You see this pipe system down here? Right now the carbon's just falling down there and it's building up. We gotta get a propane tank, cut it out, weld on a 4-inch ferrule so we can collect the carbon in the propane tank. So let's do that. So propane tanks can be particularly dangerous to cut into, raw dogging it. So even though this propane tank is empty of propane, like I vented it all out, I'm going to drill a small hole in it where I'm going to be cutting out, around the area I'm going to be cutting out anyway. So it's not going to make a bloody difference, will it? But I drill that small hole so that way if there is some extra propane in there under any type of pressure, it's going to get released. And of course, drilling it is not going to make a spark to ignite that propane versus me taking my bloody cutting wheel. That will absolutely make a spark. So let's go ahead and do this. Boom, just so I got this distiller kit which is made for wine, but I'm making wine out of plastic, so who gives a damn about what the hell it's made for? Alright, so let's go and put this together. Now, this pipe here has a slot in it, and that slot is meant for us to be able to put some copper mesh in to increase the surface area, and which will help with better liquid separation in the process of distillation. That probably sounded like a bunch of alien stuff I just said there, a bunch of gibberish, but in short, this is going to make it a lot better. Our products come out a lot purer. So, we'll just jam this in there. It's going to increase the surface area. Basic pipe system here. 2 shotgun condensers, this side, a thermometer attached to this pipe, this elbow here. Now let us know the internal vapor temperature, as well as a sight glass so we can see the vapors traveling up. Boom. Alright, so the distiller is done. As you saw, it was very basic once the tank was done. Now all it is a matter of getting insulation around the pipes and the distiller itself. But like I said, the basic principle of it is completely done. This is going to be a vacuum distiller, so this output pipe coming on this side is going to go to a vacuum, so we can get this thing under vacuum, not have to add in as much heat to get products coming over. And I had a valve that I was going to use over that sight glass so we could keep the vacuum in the machine when we go to take a look at our product, but the valve I have is broken, so I'm going to have to figure out something else to do with that situation there. Some huge changes are coming. You see this mess of all these different cables to different circuits? That's about to be gone. See this mess of all these transformers and capacitors? All of this is about to be gone. Heck, even this makeshift board, piece of freaking wood, sawhorses, this ghetto crap, all about to be gone today for good. All this is about to be replaced. 220 power supplies, 220 power, in a nice, organized power cabinet. Let's do it. Heck, even this, we have this fantastical machine here, so complex, sophisticated looking, than just a Coleman cooler. Even that's being replaced today. A lot of money has been spent on some humongous upgrades for this machine. I want to thank everybody for everything. The merch, the GoFundMes, the Patreons, the memberships on YouTube, the Super Chats. Like I said, you guys literally make this project alive. This is completely crowdfunded. It's been a few $1,000s of upgrades you're about to see right now. But all of this stuff, less professional stuff, just kind of jerry-rigged together, is completely gone now today. Watch. Yeah, this looks a lot better without all that ratchet stuff around, right? The only thing I left hooked up was the fan circuit, but that of course is going to be changed ultimately as well. So this here is a recirculating cooler. This was about a $600 recirculating cooler. Now I did not know it was this big. These are usually made to cool down the water for plasma torches and things. I was looking to get a smaller one because with this being so big, it's going to be overkill. For example, it's going to, this, first of all, the capacity of this is 1 gallon. You definitely don't need 1 gallon of water. Of course, I don't have to fill it up all the way, so it takes less energy to cool down that water. But anyways, this is way better than what I was doing before, putting ice in there, because you know that's so variable with the temperature of the water as well. This is gonna turn on a compressor to cool down the water to a certain temperature, then it'll turn off that compressor when the water reaches that temperature, then you get it, turn it on when it reaches that, turn it off. So that's nice about this. So this is just hooked up to the condensing system. But like I said, this thing is way overkill. The pump in here, like the flow rate is crazy, the pump in there is crazy. So honestly, if I'm keeping it real with you, I'm going to hook up these same lines to the condenser of the distiller because it has so much pressure, and obviously this thing can handle that many condensers at once that it doesn't make sense for me not to. And I'm also going to, the good thing about this being overkill is if this isn't enough to get all the oils we need out the machine and pretty much get every liquid before it hits these pumps, I can always add more condensers and not have to worry about getting a bigger recirculating cooler. Because right now we have 4 condensers, but I might, you know, especially since we're under vacuum and we're constantly pulling the vapors out so quickly, I might need 6 or 8 condensers. And that, you know, the amount of condensers is not going to increase the amount of electrical consumption. Because right now, with this thing having the compressor on, right, when it's the compressor and the pump, this thing is pulling 5.4 amps, right? And we have to remember that I'm kind of limited on how many amps I can use total for this whole machine. So we know this thing has to be on the whole time, and we know this thing has to be on the whole time, and this thing, I need to actually see how many amps this pulls, but I'm sure that's variable as well. When this thing doesn't have the compressor on, it's only pulling about maybe, yeah, it's less than an amp without the compressor on. So just the pump is pretty low, but well, as soon as that compressor turns on, the power consumption goes up by a lot. So that's something we have to keep note of. So we may not be able to run a total of 9 magnetrons with all these other sophisticated technologies that we're having in, let alone the motor, right? The motor to spin the blades, plus the feed motor for the auger system. Once I add that, it's looking like we may only be able to run, you know, 6 to 7 magnetrons total off of just 50 amps. But that's not that bad of a thing because we've already seen that 6 magnetrons is more than enough. And we also know that these power supplies are going to up the game because they're switch mode power supplies here. 1,000 watts out consistent. So it's not like half duty cycle. So 6 may be enough, maybe 7. But, you know, I don't think we can run 9. We definitely can't run 12 off of 50 amps because all these things have to be hooked up to the same circuit so I can know the overall power consumption.